What's up, my fetchas? Today we are going to talk about solving. So, we've been talking about in all of algebra, there are two types of problems. Okay, just a quick reminder. What are they? That's right, solve and simplify. Now you have just completed chapter 1, okay, and we did simplify problems. But now you're going to begin chapter 2, and we're going to be talking about solve. Remind me again, what is the anatomical structure that allows you to know if it's a solve or a simplified problem? It is the equal sign, okay? So all the problems that we're going to be doing in our homework tonight for sections 2.1, 2.2, 2.3, and for the rest of this chapter, every one of them is going to have an equal sign. Okay, I'm going to erase this. This is just a review. Okay, one last look. Boom. So, before we begin, I want to first teach you a law. It is called the balance rule. The balance rule. Nicole's my photographer today. Nicole, can you see this good?
Yeah.
All right, sweet. The balance rule. So the balance rule you're familiar with. It says that anything we do to one side of the equal sign, comma, we must do the exact same to the other side. Okay? So we've been talking about math is the manipulation of numbers to look different but remain the same. So if I have the number 23, that equals 23. So there's an equal sign right there. We have an equation. If I subtract 2 from this side, I now have 21 equals 23. Is that a true statement? Of course it's not. Okay? But if I subtract 2 from this side, do the exact same thing to the other side of the equal sign, 21 equals 21, I maintain my equality. If I divide this side by 7, I get 3. Does 3 equal 21? Of course not. Okay? But if I divide this side by 7, I still have 3 equals 3. If I add 10 to this side, I'll get 3 equals 13. So it doesn't matter which side we start with, but that's not a true statement. If I then say, well, what if I add 10 to this side? Then I get 13 equals 13, and it remains the same. This is the balance rule. So important. Everything we do in the solve realm, this is one of our most powerful tools, is the balance rule. Okay, I want to teach you guys something pretty awesome here. This is what we call the 3-step process to solving. The goal when we solve an equation is to get x alone. Now, why is x in quotation marks? Because x represents every variable. We could say get the y alone, the b alone, the a alone, but we're just going to say x for sake of ease. We could say get the variable alone. That is a true statement. We're going to say that our goal is to get the variable or x alone. This is a really cool tool. If you learn these 3 steps, you've learned everything you need to know for chapter 2. So our first step is we have got to simplify the equation. There are 3 things we're going to do to simplify equations. The first is to get rid of fractions. Now I got to tell you guys, I'm putting some things on the board right now that we're not going to use until our next lecture in class. But I want you to see the whole process together. We're going to get rid of fractions, and the way we do this is we multiply every term by the LCD. The second thing is we are going to distribute, what do we distribute? Parentheses. And finally, we are going to combine, that's right, LT for like terms. After we do that, though, we do need to get all of our x's, again, the variables, to one side. So all of this we are going to cover in our 2.3 second lecture. Okay? So the next time that we meet and discuss things, we'll talk about this. Today, we are actually going to work backwards, and we're going to talk about the addition and the multiplication principles. Okay? So these are what we are discussing in sections 2.1, 2.2, and the beginning of section 2.3, and that's what we're discussing today. But you put all of this together, the three-step process to solving, and this is a really powerful tool that we're going to use to solve every equation in this chapter. Again, we'll be discussing the whole thing next time more, but today our focus is on the addition and the multiplication principle. So that's where we're going to take you for the rest of this lecture. Go ahead and pause at this point in time and take some notes. This would be awesome to write all of this down in your notes. I'm going to continue. Let's go ahead, Nicole, and let's focus on this board right here. Okay. So the first principle is what we call the addition principle. Now, Nicole, can you see this portion of the board right here?
Yes.
All the way to here?
Yes.
Okay, cool. Nicole is our awesome photographer here today. So the addition principles are really interesting. They follow, if we say, the addition and the multiplication principles. They follow some definitive steps. So first thing I want to ask you guys, if I have x plus 3 equals 10, okay, what does x equal? Yes, 7. You can totally do that in your head. But we're going to learn in algebra, the first thing we're going to do is we're going to ask, who is sharing sides with x? Okay? Who's sharing sides with the variable? That's right, 3 is. Our second question, what are they doing to x? Okay? So what is 3 doing to x? It's being added. Okay, very good. You are now going to do the opposite to both sides. Do the opposite of addition to both sides of the equation. And this brings us back to our balance rule. Whatever we do to one side, we got to do the same thing to the other. So we look at this. Remember, the goal of solving was to get x alone. Is x alone right now? It's not. 3 is sharing sides with it. I got to get rid of that 3 in order to solve for the variable. So who is sharing sides with x? 3 is. What's it doing? It's being added. What are we going to do? The opposite. The opposite of addition is subtraction. So we will take and we will subtract 3 from this side of the equation. Whatever we do to one side, we must do to the other, the balance rule. And so we have these canceling, and we get x equals 10 minus 3 is 7. So again, we go back, our original equation was x plus 3 equals 10. Okay? And we came up with x equals 7. So what you did in your head, we can do with algebra. Now, why is it important to be able to do it with algebra? Well, what if I have x minus 2 equals negative 12? Okay, now, you still see this okay? X minus 2 equals negative 12. We can't necessarily do this in our head as quickly. Who is sharing sides with x? 2 is. What's it doing? It's being subtracted. What's the opposite of subtraction? Addition. Okay, so who is sharing sides with x? 2. It's being subtracted. So we're going to add what we do to one side of the equation, we must do to the other side. Okay? These cancel each other out. Well, the reason I write this up here is just so you can see our original equation. And then 12 plus 2, or negative 12 plus 2, you little negative number aficionados, negative 12 plus 2 is negative 10. So x equals negative 10. Now let me show you something really cool about solving. Tonight in your homework, you're being asked to solve these simpler equations, and then it says to check your answers. But a little different than checking them in the back of the book, you're going to plug the answer back into the equation and solve. So our original equation was x minus 2 equals negative 12. We just stated that x equals negative 10, so where there's an x, we will substitute in a negative 10. So now we have negative 10 minus 2 equals negative 12. Now we learned last week about negative numbers, that we change all subtraction to a form of addition. So minus is the same as plus a negative. Negative 10 plus negative 2 is negative 12 equals negative 12. Check. That is a true statement. So when you check your answer, you're not going to get the answer again. You're going to get a true statement. Let's say that you put something in that was false. For instance, let's say that when you solved x plus 3 equals negative 10 and you subtracted 3 from 10, for whatever reason, let's just say that you decided that x equaled 13 accidentally, even though that's not true. So you come back here, get the original equation, x plus 3 equals 10 is the original equation. We plug in 13. We have 13 plus 3 equals 10. 13 plus 3 makes 16 equals 10. That's a false statement, okay, because this is not a true answer. Plug 7 back in. 7 plus 3 is 10. 10 equals 10. This is your true answer. So the cool thing about solving is we can always plug our answers back in and check them. Now the addition principle could aptly be named the addition or subtraction principle. It is not called that. It's called the addition principle. But notice here we are adding things, here we're subtracting things. So this covers section 2.1. We've actually finished and completed our discussion on section 2.1. You're going to be given problems where numerical values are being added or subtracted to the variable. Here we're having addition, here we're having subtraction. Okay. Again, this might be a really good time to pause and take some notes, okay? But I do want to bring you back to this thought here. The addition and the multiplication principles both are governed by these three concepts. Who is sharing sides with x? What are they doing to x? And you're going to do the opposite to both sides. And this is where we started our discussion, the balance rule. The balance rule allows us to manipulate equations to look different, but still remain the same. So go ahead and pause and take notes on this, and we'll discuss the multiplication principle. Can you see me over here, Nicole?
Yeah.
Okay. So now we're discussing the multiplication principle. Now the multiplication principle could also aptly be named the multiplication or division principle. It's not, it's just called the multiplication principle. So I'll ask you guys, if I have 3x equals 15, what does x equal? Yeah, absolutely, it equals 5. You can do that in your head, super easy. You know that. But I want to go back to our three steps we were talking about, how the addition and multiplication principles are governed by who is sharing sides with x. Remember, our goal in solving because it's an equal sign, our goal in solving is to get x alone. Who's sharing sides with x? 3 is. What's it doing? If it's written next to it, nothing's written in between. No, yep, multiplication. So this means 3 times x. Opposite of multiplication is division. Whatever you do to one side, balance rule, we must do to the other side. 3 divided by 3 is 1. 1 times x leaves you just with x. X is now alone. 15 divided by 3 is 5. What you did in your head, we just did with algebra. We can check our answer. So on our homework tonight, we would show these steps just like this. Then we would write check. And then we would say, all right, 3x equals 15 is my original equation. Wherever there's an x, I now know it equals 5. So I'll have 3 times 5 equals 15. Indeed, 15 equals 15. Check. That is true. And so that makes my answer a true answer. Now, what we can do in algebra, we can now take something a little more complex, because we could do this one in our head, but what if I had x over negative 2 equaled negative 12? Okay, now, who is sharing sides with x? Negative 2 is. And negative 2 is being what? Divided. So the opposite of division is multiplication. Now this is really important. You have x over negative 2. If you multiply this side by negative 2, whatever you do to one side, you have to do to the other. So you can take negative 2 and multiply it times negative 12. Notice that I didn't multiply this by 2. I multiplied it by negative 2. If you only multiplied it by 2, you would have a negative left over here. And I don't want to know what negative x equals. I want to know what x equals. Okay? So, these cancel. X is now all alone. And negative 2 times negative 12, what's a negative times a negative? That's right, a positive. 2 times 12 is 24. X equals 24. So that's how you'll do your homework again tonight. Then you'll write check,